Okay, now we are ready to start section 2.2, linear equations and problem solving. In this section, we're going to be looking at problems that are going to require us to create equations and solve word problems with the equations that we create, knowing from section 2.1 how to solve them using the opposite of the order of operations. So let's start with mathematical modeling. It is the process of using algebra to solve problems that occur in real life situations. So we're going to basically be reading some word problems and then creating equations from those word problems and then solve them. So in example 1, we are going to write algebraic expressions that represent each following problem, and then we're going to solve for the variable. So example 1 in this one says you have a job on an assembly line for which you are paid $10 per hour. So I'm going to underline the important information. $10 an hour plus 75 cents per unit assembled. Find the number of units produced in an 8-hour day if your earnings for the whole day are $146. Okay, so that's a lot. The first thing that you want to do after you underline all of the important information you think that you're going to need for your equation is determine what the variables are going to be. And sometimes word problems don't tell you what they are. You have to kind of look into the situation and figure it out. So a lot of the times you'll find that information in the question, which will be the last sentence of the word problem. So find the number of units. That's what we want to find. So that's going to help us determine what variable we will need and what it represents. So find the number of units produced in an 8-hour day if your earnings for the day are $146. So we know here in this problem that you are going to be making money at your job, and you're making money based on how much you're getting per hour and also how many units you're assembling. So let's start out with those variables here. I like to use X and I like to use Y because these are the variables we use when we graph. So even though they might represent something else like number of this or number of that or cost, I like to just always use X and Y instead of another letter of the alphabet. So if we're looking at this problem, sometimes it makes more sense to figure out what y equals, what the whole problem is about, what is like the dependent variable. And that's going to be the amount of money you're going to earn. So y is going to be your earnings or the amount of money. Okay, that's what we're trying to find. How much money, well, they tell you the amount of money you make is $146. So they tell you that, but we're trying to find the other variable. We're trying to figure out the number of units you produce. So I can see here from where it says find the number of units. That's what X is going to be, the number of units. Okay, so let's create an equation. So we know that our earnings, which is Y, is equal to, up here we can see we get $10 per hour plus 0.75 cents per unit. All right, so our equation is going to be 10 times the amount of hours we work in a day. Since we get paid $10 per hour and we work 8-hour days, they tell us this right here. I'm going to multiply 10 by 8. So that's just $80 just for being at work. Plus, we get paid 75 cents per unit that we assemble. So here's the equation we would use to figure out the amount of earnings we would make and the amount of units we would produce. We make $10 per hour. We work 8-hour days. So this number is going to be 80. So this is going to be Y equals 80 plus 0.75x. Now, we are trying to figure out how many units we produce in that 8-hour day if our earnings are $146. So I'm going to replace 146 in for Y, and I'm solving for X because they ask us to find the number of units. So I'm going to solve for X. Now that I have my equation set, I'm going to use the opposite of the order of operations, and I'm going to first subtract 80 from both sides. Well, 146 minus 80 is 66, so this equation turns into 66 is equal to 0.75x. To get rid of the 0.75, I divide both sides by 0.75, and 66 by 0.75 is 88. All right, so I have my answer as 88. When you have a word problem, it's important to also write what your answer represents. So in this problem, I'll change my color to green. We produce 88 units. So in this problem, we produce 88 units in an 8-hour day, making $146. Okay, the next problem. You've accepted a job at an annual salary of $40,830. This salary includes a year-end bonus of $750. You are paid twice a month. What will your gross pay be for each paycheck? All right, so I should have, as I read that, I should have underlined the important information, but here we go. Our annual, that means once a year, salary is this. This includes one year-end bonus of $750. So we have $750 as just a bonus. And we are paid twice a month. That's really important. We want to know what our gross pay is for each paycheck. That's a fancy way for saying how much money will be in each paycheck. So that's what we're trying to find. So when you're creating your equations, it's helpful to write out x equals and y equals to help you brainstorm and help you create what these things are. Well, in this problem, we are dealing with a lot of money, right? So y would be equal to the total amount, so like your total salary. Okay, so that's the total amount of money you make in a year. All right. And then x would be your paycheck money. So if we use these variables, it'll help us determine how to set up our equation. So our equation, our total salary, y is going to be equal to our payment for each paycheck plus our year-end bonus. So if we are paid twice a month, let's just look up this right here. If we're paid 2 times a month, and there's 12 months in a year, it's important to realize that when we're creating this equation, we would need to multiply 2 times 12, and that would be 24 paychecks. So 24 times x, because x is the amount in each paycheck, plus the $750 year-end bonus is equal to our total salary. Now, they told us that our total salary is $40,830. So I'm going to replace y with $40,830. And then when I do that, I will be able to solve for x. So the first thing I'm going to do is subtract $750 from both sides. $40,830 minus $750 is equal to $40,080. And then when I divide that by 24, I'm going to get that each paycheck is $1,670. Right, so what will your gross pay be for each paycheck? The final answer for this problem would be $1,670. All right, the next one is very similar to this one. So why don't you pause the video, try it, and then unpause to watch me go over it. Okay, let's go over it. You have accepted a job at an annual salary of $37,120. This salary includes a year-end bonus of $2,800. You are paid now every 2 weeks. What will your gross pay be for each paycheck? So this problem is very similar to the last one, except for the fact that instead of getting paid twice a month, we are getting paid every 2 weeks. So we know that in a year there's 52 weeks. So if we're getting paid every other week, we would take 52 and divide that by 2, and that means we would get 26 paychecks a year. So when we're using our equation, we're going to use the same variables as before. So these variables are still going to apply. So x is going to be equal to paycheck, y is salary. So I'm not going to write that again. But now instead, our equation is going to be our salary is going to equal 26 paychecks times the number of times how much money each paycheck is, plus our year-end bonus of $2,800. That would be our equation for this one. The 26 and 24 are different because 24 represents twice a month, and there's 12 months. 26 is every other week. That's 26. All right, so I'm going to insert the 37,120 in for y, and then solve for x. To do that, step one, I'm going to subtract both sides by 2,800. And when I subtract 37,120 minus 2,800, I get 34,320. Last thing I'm going to do is divide both sides by 26. And that's going to tell me that each pay is going to be $1,320. All right, so my final answer for this one is the gross pay for each paycheck is $1,320. So that's using linear equations to solve word problems. Next, what we are going to do is solve some percent problems. So if I scroll down, we have a couple ways to solve percent problems. One way that I'm going to show you is by using a percent equation. So in example 2, it gives you a problem. 3 is 50% of 6. Now I know that's true because 3 is half of 6. 50% is half. Using numerical values, that means that 3 is equal to 0.50 times 6. All right. There's a fancy equation that we can use for finding the answers to percent problems. It's called the percent equation. Now, technically, we can use variables to represent these numbers in the equation, but there's actually a really easy way to think of this and to remember this. Here's the equation. Is equals percent times of. Now you're wondering, like, what does that even mean? You just have to remember this equation and it will work every single time. Now, it's really important to note that this percent here, it must be in decimal form. So as long as you put the percent in decimal form and you put the correct numbers in the right spot, this will always work. So the formula is equals percent times of. All right, so the way that this works is when we're solving a problem, we're going to look at the problem that it's asking, and then we're going to put the numbers in that are closest to the word is and closest to the word of and the percent in decimal form, and then solve. This problem is asking, what is 65% of 800? So, to do this, what we would do is use the formula is equals percent times of, and we're trying to find what is. So this is the variable we're looking for. X equals, we take 65% and we put it into decimal form. To do that, you just take the percent sign, wherever the percent is. If there's already a decimal in it, then you move it 2 spots to the left. If there is no decimal, we know there's an invisible 1 right there. You move it to the left twice, and it becomes 0.65. And then we multiply this by the number closest to the word of, and that's 800. That's literally how it works. The number closest to the word is goes before the equal sign. The percent goes to the right of the equal sign, and you multiply that by the number that's closest to the word of. And it works every single time. When we multiply, we're going to get x is equal to 520 for the first one. We'll try the second one together. What is, so we're trying to find the is number again, that's x, equals 0.4%. So 0.4% has a decimal place already. To take this and put it into decimal form and not percent form, you move it once, twice to the left, add zeros each time you pass over a number that's not there, and this is 0.004 for my percent in decimal form times 150,000, like this. when I multiply these together, I'm going to get 600. So 600 is the answer. What I want you to do is now pause the video and try C on your own. Okay, let's go over letter C. We're trying to find we're trying to find X, 250%. So 250% has an invisible decimal point right there. We're going to move this to the left 2 spots, 1, 2, and it's going to be 2.5. Now this makes sense because every time you multiply by a percent greater than or equal to 100%, the number is going to get bigger. So when we do this and multiply 2.5 times 32, we're going to get the answer is equal to 80 because the number is going to be bigger than it since we're looking for 250% of it, which is going to make it bigger. All right, so the rest of the problems are a little bit different. We're still going to use the same formula, but now we have 416 is. 416 is closest to the word is, so in the formula up here, is equals percent times of. 416 is going to go in this place, not X. Next, we have the percent number. 65% is 0.65. And now we're solving for of what number? So the word of is what we're looking for in the equation, so this is going to be the variable X. So now we're going to solve this equation a little bit differently because to solve this one, we're not just going to multiply, we actually have to divide by 0.65. Whenever you take a number and divide by a decimal, it actually makes the answer bigger. So when you divide by 0.65, you're going to get the answer is 640. So 416 is 65% of 640. And you can always check by doing 0.65 times 640, it'll equal 416. Why don't you pause the video and try E? Okay, let's go over E. 84 is, so 84 will go here. 24% in decimal form is 0.24. Of what number is what we're trying to find. So here's what your equation should look like. To solve, we divide both sides by 0.24. And 84 divided by 0.24 is 350. Okay. Letter F is different than letter E. It says 28 is what percent of 80? So 28 is closest to the word is, so 28 goes here on the equation before the equal sign. And we are trying to find the percent. So the percent is actually the variable we're solving for. They give us the of number being 80. So this is what we have. 28 equals x times 80. To solve this, we would divide both sides by 80. And when I divide 28 by 80, I'm going to get a decimal 0.35. Now, it's important to realize that this decimal really represents a percent, since what we're looking for is what percent. So you then have to move this 2 spots to the right and add the percent sign. So the final answer for this one is 35%. What I want you to do is pause the video and try the next one. All right, letter G, let's go over it. 496 is what percent of 800? So it's going to be 496 equals what percent times 800, like this. To solve, I would divide both sides by 800. And when I do that, I get 0.62 is my answer, which then remember to convert of this value by multiplying by 100 or moving the decimal point 2 spots to the right. And our final answer is 62%. The last topic we're going to review today is example 3 on the other side. So flip your packets over to the last page. We're going to go over these problems here because they have to do with percents as well. So percent applications. So a real estate agency receives a commission of $13,812.50 for the sale of a $212,500 house. What percent commission is this? So when you are selling your house, you give a percentage to the real estate agency or the real estate agent that helps you. And that is based on the total price of your house. So this right here is just a part of the total. Just like if there's a 50-point quiz and you get 40 points out of 50. To find your percentage, you would just do 40 divided by 50 and you would get that 80%. Same thing here. We're going to take the part of the commission, the $13,812.50, and we're going to divide this by the total amount of the house. And when I do that, I'm going to be left with a decimal. This answer, when you divide, you get 0.065. Next year, we're going to make this into a percent by moving the decimal 2 spots to the right, and this is 6.5%. So you basically give to the agency 6.5% of whatever your house sells. The next one probably, you maybe not right now, but I'm sure like when you used to go out to dinner all the time, if you go to a spot that there are waitresses and waiters, you give a tip based on the meal. So if you want to leave a 15% tip for a meal that costs $32.60, to figure out the tip, you would take the 15% and you would put it into decimal form, and you multiply by the total bill, like this, and it equals $4.89. So when you have application problems like this, the rule from the page before still applies. It's just these application problems, you might not see the words is and of as clear as the other ones. So for these problems, I like to just understand what's going on and try and determine what do I do. Do I multiply? Do I divide? And then for the last one, a new car costs $29,750, which is approximately 115% of what comparable car costs 3 years ago. What did the car cost 3 years ago? All right, so the new amount is this, and that's 115% of what it used to cost. To figure this out, you could use the formula that we used before, and the formula is like is equals the percent times the of number. And if we're using that formula and this car is the original, this would be here, $29,750. And if we use this percent in decimal form is 1.15. And then times what we're trying to find, this is the equation we could come up with. Then we would divide both sides by 1.15. And we're going to get the cost of the car 3 years ago was $25,869.57, which makes sense because it used to be cheaper and then it increased by 115%.